Here is the problem. You should calculate about how many number of moles of glucose present in the 540 grams of glucose. That means he gave you some weight of glucose, that is 540 grams. Before going to calculation part, you should need to know about the molecular formula of glucose is the C6H12O6. Then after you should calculate about molecular mass of this glucose formula or glucose molecule. So if you calculate, then you will get 180 grams is the molecular mass of the glucose. Then coming to the formula, what is the formula for number of moles? Number of moles equal to number of moles represents n, small n, then given weight by molecular mass. So what is the given weight here? Given weight is the 540 grams and molecular mass is the 180 grams. So this is 3 moles. 18 3s are 54. 3 moles of glucose present in the 540 grams of glucose. Here is the problem. You have to calculate about what is the weight for 0.1 mole of Na2CO3. Na2CO3 is nothing but sodium carbonate. Before calculation part, you should need to know about molecular mass of Na2CO3 is the 106 grams. Now coming to the calculation part, you know about the formula for number of moles, that is weight by molecular mass. So weight equal to n into molecular mass. So number of moles, this n value already given in the data. So you can write that 0.1 into molar mass of Na2CO3 is the 106 grams. So that you will get the value 10.6 grams of Na2CO3 is equal to the 0.1 mole of Na2CO3. In this problem, you should calculate about how many number of molecules present in a 5.23 grams of glucose. For calculating number of molecules, you should know the formula. Number of molecules in a substance equal to n into Avogadro's number, small n this one. This small n equal to given weight by molar mass into Avogadro's number. Now you can substitute all these values in this formula. So given weight is the 5.23 grams and molar mass of glucose is the 180 grams. Avogadro's number value you already know. So 5.23 grams upon 180 grams into 6.023 into 10 power 23 molecules. So if you calculate these two numbers, you will get 31.49 upon 180 into 10 power 23. So this 0 and 1 0 from this 10 power 23 will cancel, and see, if you simplify this one, you will get 1.74 into 10 power 22 molecules present in the 5.23 grams of glucose. In this problem, you should calculate about what is the molecular formula of a compound by using its empirical formula. Same, what is the formula for calculating a molecular formula of a compound? You can take this formula for that one. Molecular formula of a compound equal to empirical formula taken n. How can you get this n value? This n equal to molecular weight upon empirical weight. See, we already know this molecular weight is the 90. We have empirical formula. From this empirical formula, you should calculate its empirical weight. See, empirical weight you can calculate here. Carbon plus 2 hydrogens plus oxygen. So carbon is 12 plus 2 into 1 plus 16. So 12 plus 2, 14 plus 16, it will gives you 30. Empirical weight is the 30. So you can substitute this 90 and this 30 in this formula. 90 upon 30. So this n value you will get 3. So that molecular formula equal to, empirical formula is what? CH2O taken thrice. So you can multiply with this 3. C3H6O3. This is the molecular formula of that given compound. In this problem, we should calculate about what volume of H2 gas required to convert 0.795 grams of copper oxide to the copper and water at STP conditions. First of all, you should write balanced chemical equation for this problem. Copper oxide reacting with hydrogen gas, they will form solid copper and water. This is the balanced chemical equation. Here this copper oxide is the 1 mole. It needs 1 mole H2 and they will produce 1 mole of copper and 1 mole of hydrogen, water. So it's a balanced chemical reaction. Now this 1 mole of copper oxide weight is what? That is 79.3 grams, 79.5 grams, because copper's atomic mass is the 63.5, oxygen's atomic mass is the 16 grams. So you can add those two things, then you will get 79.5 grams of copper oxide. Then this 1 mole of copper oxide needs 1 mole of hydrogen gas. That gas is in the volume, you should need to tell. So that 1 mole of H2 equal to the 22.4 liters of hydrogen gas needs to react with this 79.5 grams of copper oxide. Now then this 0.79 grams of copper oxide needs how much liters or how much of hydrogen gas to form copper and hydrogen, copper and water molecule. Now coming to the calculation part, 79.5 grams of CuO needs 22.4 liters of H2 gas. Then 0.795 grams of CuO needs how much, how many liters of H2 gas you should calculate. So 22.4 into 0.795 upon 79.5. So these two will cancel out. 79.5.01 ja. Okay. So then you can multiply. You will get 0.224 liters of H2 gas needed to convert CuO into Cu and water molecule. In this problem, we should calculate about how much volume of oxygen is required to complete burning of acetylene. To calculating about this one, you should write a balanced chemical equation for this problem. Acetylene reacting with oxygen, C2H2 is the acetylene, then they will form carbon dioxide and water. It's not a balanced chemical equation, so you can multiply with 2 to the acetylene and multiply with 5 to the oxygen molecule. Then coming to the right hand side, here 4 carbon atoms, so that you can write 2 with carbon dioxide and 2 with water molecule. Now it's a completely balanced chemical equation. Coming to the data, Actually here it is in ml, so that volume of gases also we should take in ml. So here 2 molecules of acetylene needs 5 molecules of oxygen, or nothing but 2 moles of acetylene needs 5 moles of oxygen. So actually we already know at STP conditions 1 mole of any gas is equal to the 22,400 ml volume. So that here 1 acetylene equal to 22,400 ml. So 2 acetylene molecules are there. So that you can multiply with 2 into 22,400 volume of this acetylene, and then here also 5 into 22,400 ml. So now you can frame the calculation part for this problem. Here 2 into 22,400 ml of acetylene needs 5 into 22,400 ml of oxygen. So 100 ml of acetylene needs how much oxygen you should calculate, so that 5 into 22,400 into 100 upon this one, you can write 2 into 22,400. So here this one and this one cancel out with each other, 250s. So you will get 250 ml of oxygen gas is needed to convert or to complete burning of acetylene gas. This is about this problem. We should calculate about what is the mass percentage of different elements present in a given compound. That given compound is here sodium sulfate. What is the sodium sulfate's formula? You can see that is Na2SO4, and after that you can write what type of atoms are here, sodium and sulfur and oxygen, and then after what is the molar mass for this compound, that is 142 grams of molar mass for the sodium sulfate. Then after, what is the formula to calculate mass percentage of any element present in a compound? That is, see, number of atoms into atomic weight of that element upon molar mass of the given compound into 100. See, now coming to the calculation of mass percentage for the sodium. 2 sodium atoms are here and its atomic mass is the 23 upon 142 into 100. If you calculate this one, you will get 32.39 percentage of sodium present in the sodium sulfate. Then you can come sulfur. What is the mass percentage for sulfur? See, mass percentage of sulfur equal to, how many sulfur atoms are here? Only one sulfur atom. Its atomic mass is 32 upon 142 into 100. If you calculate this, you will get 22.54% of sulfur present in the Na2SO4. Then coming to oxygen's mass percentage, this is, see, here oxygen is in 4 atoms are there, its atomic mass is 16 upon 142 into 100. Then you will get 45.07% of oxygen is present in the given compound. That given compound is the sodium sulfate. In this problem, if you see, what volume of carbon dioxide liberated if 4 grams of calcium carbonate is going to be heated. Then you should write a balanced chemical equation for this. CaCO3 will gives you calcium oxide and carbon dioxide. Everyone is in only ratio of 1 mole. I mean, this is 1 mole. If it is going to be heated, it will produce 1 mole of CaO and 1 mole of CO2. So this 1 mole of CaCO3 equal to 100 grams. Here he is asking volume, so that you should take liters of carbon dioxide. So 1 mole of carbon dioxide equal to the 22.4 liters. So that here see 100 grams of CaCO3 releases 22.4 liters of CO2. Then 4 grams of CaCO3 releases how many liters of carbon dioxide? You should calculate 22.4 into 4 upon 100. See, this is 16, 4 2 is 8, 9, 89.6 upon 100. So you can write it like this: 0.896 liters of CO2 will be released if 4 grams of CaCO3 going to be heated.